Welcome to the Math Record. Today I'll be covering the second part of the ICTM State 2017 Division AA Precalculus, which I'll be answering questions 15, 17, and 20. Okay, question 15. 5 sine of 4x plus 2 cosine of 4x equals a sine of bx plus c. So I'm just going to split up sine of bx plus c as, so take out your a, parentheses. So that will be sine of bx times cosine of c plus sine of c times cosine of bx. So that's just a trig identity sum of sine. So we can split it like this. So if you imagine your b is equal to 4, then sine of 4x, where is that? That's sine of 4x with a 5. So that means a times cosine of c should be your 5. And we could do the same case here. So a times sine of c is in front of your cosine of 4x. Cosine of 4x is the 2. So we can square both of them. So a squared cosine squared of c equals 25. A squared sine squared of c is equal to 4. Add them together because cosine squared plus sine squared is 1. So that's just a squared times 1 is just a squared. So that's 29. So that means a is square root 29. So we got our value for b and we got our value for a. So that's just 4 plus square root 29. And that will be your answer for 15. Okay. And then question 17. So C and D lie on BE such that AC and AD trisects the angle BAE and ABE. BC is 2, CD is 3, and DE is 6. The parameter of ABC, which is the small triangle on the left, is in this form. Add the coefficients. Okay, so let's kind of draw this out. And this. And then we have and then we trisect the angle, so something like this and this. So they said that the angle of this is equal to this is equal to this. That's what it means to trisect. And they say this is 2, this is 3, and this is 6. Okay, so we need to find. So we could use something called the angle bisector theorem. So since these are bisected, then this divided by this is the same as this divided by this. So that means the ratio of these is 3 to 6, which is 1 to 2. So that means we could call this x and we could call this 2x because we don't know what the length is. So x is just some kind of scalar. So we could do the same thing now with x, 2x. So we could do the same thing now with these two. So that means this divided by this is equal to this divided by this. So we have 2y to 3y, right? I can't use x again because it's probably different scalars. So we could probably make a system. So using just this triangle, these two triangles, we could use something called Stewart's theorem, which is the side length squared, which is x squared times 6 is 6x squared, plus 2x squared, which is 4x squared, times your 3, which is 12x squared, is equal to your diagonal squared, which is 9y squared, times 3 plus 6, which is 9. So 9 times 9y squared is 81y squared. And then we have the total side length, which is 9 times 3 times 6. So 9 times 3 times 6. And that is 162. You'll probably just use your calculator for this. So we can speed up the math. And then 2y, then for these two triangles, we have 2y squared, which is 4y squared, times your 3, which is 12y squared. So this is just still Stewart's theorem, so we used it twice, so we get some systems. And then 3y squared, which is 9y squared, times 2 is 18y squared, is equal to x squared times your distance, which is 5x squared, plus 5 times 2 times 3, so that's 10, and that's 30. So this sum up to 18x squared equals 81y squared plus 162. And the other equation is 30y squared equals 5x squared plus 30. So we can simplify the first one by dividing by 9 to get 2x squared equals 9y squared plus 18. And then simplify the one dividing by 5, so that's 6y squared equals x squared plus 6. Okay, so I see a 2x squared and an x squared, so let's make this one negative 6, so move it to the other side. And then we multiply by 2, so we could say equal to each other. So that's 12y squared minus 2 times 6, which is 12, is equal to 9y squared plus 18. So that means 3y squared is equal to 12 plus 18, which is 30. So 30 divided by 3 is 10. So that means y is square root 10. Okay, so y is square root 10. So let's put it under this. So y equals square root 10. So to find our x, let's just plug it back into one of our original equations. Let's just use this equation. So that means y is square root 10. So y squared is 10. So 90 times 10 is 90. Plus this 18 is 108. 108 divided by 2 is 54. So that means x is square root 54. Okay, so x equals square root 54. So to get our parameter is 2 times y, so 2 times square root 10, plus 54 is going to be 27 times 2, or basically 9 times 6. So that will be 3 squared 6 for your x. So I just simplified it, and then plus your 2. So add your coefficients, so 2 plus 10 plus 3 plus 6 plus 2, so that's 12, 15, 21, 23. So that is your answer for number 17. So you just got to use the angle bisector theorem and the Stewart's theorem. Okay, so now we're going to answer question 20. So your math team coach probably often says there is no I in team. Since coach is also a math teacher, coach might also say there's no e to the k of I pi in team. So to the math teacher, I equals square root negative 1. Given the Euler formula e to the power of I theta, where cosine is equal to cosine theta plus I sine theta, determines the smallest possible value for 12k minus 100. So what we could do is basically e k I pi is equal to your I, because there's no e k I pi is in team and there's no I in team, so they're said to equal each other. And then basically your your theta is going to equal to k pi. So that means you could rewrite this using that Euler's formula as cosine of k pi plus I sine of k pi is equal to I. So there's only one I here, so it has to be from here. That means this sine has to be 1, and this cosine, okay, so and this cosine had to be 0. And if you kind of think about the graph for trigs, like in the coordinate plane, the only time that cosine is 0 and sine is 1 is when it's at 90 degrees. So 90 degrees in radians is pi over 2, and then every single other cycle, which is 2 pi n, where n is an integer. So every single time that from pi over 2, and then every single n with like n equals 0, n equals 1, n equals 2, every single other angle like this, which would be the 90-degree angle, is going to satisfy these conditions to make the I. So that is going to, this is our theta, so that's equal to k pi. So that means k is equal to 1/2 plus 2n equals k. So this is just 4n plus 1 over 2 equals k. So we could substitute that into our equation. So let's move this up because we don't need it anymore. So 12 divided by 2 is 6. 6 times 4 is 24n. And then 1 times 6 is 6. 6 minus the 100 is minus 94. So you could just plug it. So you could just like have 94, negative 94, and add 24 into it, becomes the smallest possible positive. So negative 94 plus 24 plus another 24, 24, 24. And you should find out that when n is equal to 4, which would make it 96. 96 minus 94 is 2. So that's your smallest possible. So your answer for 20 is 2. Okay, well, thanks for watching, and I'll see you at the next math record.